Just hello. Yeah, I can hear myself. I can hear my this thing. So I'm not sure. Hello. I can hear myself actually. This thing. So I'm not sure. Okay, cool. Hello. I can hear myself actually. This thing. So I'm not sure. Okay, cool. Hello. Yeah, I can hear myself. I can hear myself. I can hear myself on my headphone, the mic output. I can see here. Hmm? Okay, cool. Okay. Hello. I'm just gonna. Am I audible now? Am I audible now? If anyone on the chat can confirm. Okay. Meanwhile, what I'm gonna do is. Okay, cool. I don't know why. Just can. If I put the. If I monitor only, that is when you can hear me. But the weird part is if I put it in monitor, I can hear myself on a loop. It's very weird. Okay, anyways, we'll go through this today. Okay, so yeah, let's quickly go through it. Let's quickly go through it. And the point that we are talking about here is that uh, the point that we are talking about here is that you have from here to here. So I want to take this as last element again. So I wrote about this thing hmm, couple of okay, so almost 1.5 years back. So you can go to this article which I linked in already in the chat, which basically talks about how you can break down a dynamic problem, okay, dynamic programming problem. So in here, what we can do is let's name it int next max is nums of length minus 2 and next loop, let's call it 3 for I equals length minus 4, I greater than 0, I am minus 1. So in current loop should be nums of I plus next max loop, right? So you are at this house where, like, what is the maximum value that you can loot in here? Okay, the maximum value that you can loot in here is I'm gonna mute my headphone. Hello. Okay. Yeah, that is better, I think. So otherwise, I keep on hearing myself. Okay, value that you can loot in. Cool. Okay. The maximum value that you can loot now, in here basically what happens is that you have this particular thing which says, okay, yeah, I didn't drop in anything in that is so it should be good. So here what happens is that okay, value that you can loot it. Cool. What is the maximum loot that I can have at this house? So the maximum loot that I can have at this house is this plus, except this guy, whatever is the maximum that I can do from in this particular range, which will be taken care here what happens is that variable called next max loot. Right. So now, what is the maximum loot that I can have at this house? So the maximum loot that I can have at this house is this plus, okay, except this we have that. Whatever and what you have to do is current loop in this particular range. So which will be taken care of next max loop is max next loop. So now, what is the maximum loop that I can have? Next loop. The maximum loop that I can have actually have this thing plus, okay, except this we have that. Whatever and what you have to do is current loop in this particular range. So and then I'm gonna say next loop max loop is current max. So in the next iteration, when you land here, this becomes the next loop, and this comes into the range of saying that. And what you have to do is current loop in this particular range. So and then I'm gonna say next loop max is current max. So in the next iteration, when you land here, now we hear you loop next loop, and this comes into the range of saying that सब कुछ सही था, सब कुछ सही था. And then I'm gonna say next loop max is current max. So in the next iteration, when you land here, now we hear you loop next loop, and this comes into the range of saying that सब कुछ सही था, सब कुछ सही था. Can you hear me now? Am I audible now? Okay, cool. I'm gonna I'm gonna just okay, I'm not gonna listen to any music actually. I don't know, something happened. But yeah, let's continue. Okay, so like I mentioned, our next loop becomes the current loop, right? The next loop becomes a current loop, and in here I'm gonna say yeah, that's pretty much it. So in max loop that you can get it max next max loop and next loop, because those are the two variables that would be holding the first and the second slot, right? So we have to do the same thing again. where you take in the last one and you take in the second last one, which means now, so since it's a circle, we started off here. So let's do the circle first. Since it's a circle, 1 2 3 4 5 6 7 8, let's just say this is 8, this is 0. Okay. I mean, that problem would be 7, but anyways, in here what you can do is, the first thing I said, okay, I'm not going to loot this, I'm going to loot this range, right? Now I'm saying I'm going to loot this, which means I cannot loot this, right? So I have to start and end here at 1. Okay, so this is what my range would be. Okay, I hope that is clear and I explained that. So it's basically the same thing, except your ranges are changing, right? Except your ranges are changing, and then you have to say max loop is max. So let's just say 2 for now. We're not gonna properly name the variables, which means we can also copy paste this thing in here. Okay, and then it's basically gonna be the maximum of the two things that you can do, right? The two possible ways that you can go and loot in the entire I'm sorry, there is quite a huge noise in here. Yeah, okay. So that is when we are gonna say that, okay, like out of these two options, what is the maximum possible that you can do? Max loop 2 max, and that should be the code that actually works. I should the code would actually works, and hopefully it works. Let's see. Yeah, that works. I'm gonna submit this and see if that works too. That works too. But we can do a little bit better when it comes to the code quality, right? We can do a little bit better because here we are looping and we are exactly doing the same thing, right? So private, let's call it Rob, and int nums, int from, int n. Okay, so we can copy paste this thing in here. So here is the thing. Here we can pass in max and int max next loop. So this is nums dot length. So that is not also right. So here we'll go from end, and yeah, that's basically it. Turn math dot max next loop next max. I'm gonna rename these variables honestly. So I'm gonna say this. So I'm gonna call this the last loop, second last loop. Not sure if that's good names, but yeah. So technically this is the last loop, and this is the second last loop. Yeah, that would make more sense. Right? So in here we can call the function raw nums. So we have to go in here from length -4 to 0 and length minus so let's actually call this index and index. Okay, so this thing and this thing, right? So in here we're gonna send to length minus so this is the last loop and this is the second last loop, right? And for this one we're gonna go from 3 to 1, but then we're gonna be, I think I'm making a mistake. Am I making a mistake? No, I'm not. So last loop will be this. The second last loop will be this. And math.max, this thing in here. So this is gone. And this is gone. So yeah, honestly, I think we can extract it out because it becomes a little bit more readable. Max rob 1, I have no idea what to call it. Max rob 2. Yeah, and that should also be the solution. It's just a little bit more distinct, so I don't write the same for loop twice. That's all. That's all. So let's quickly check this solution. Solution. I'm gonna directly submit it. Okay, that works. Awesome. Next thing what we want to do is here, I hope it remembers the context and doesn't mess it up. Let's see. How's robber? Cannot rob first and last together. So rob this thing. Yeah, exactly. So rob from 0 to n minus 2 and from 1 to n minus 1. So use dp and then optimize the controlling variables of this thing. Makes sense. Makes sense. Okay, cool. So in here, what we're gonna do is go back to my code. So from this thing, then you use PP, optimize with rolling. Yeah, that kind of makes sense. That is kind of correct. So this is inclusive, and this is also inclusive ranges that we're talking about. Okay, cool. I think we solved another problem, and we can move on to the next. So in here we solved 25 problems. Awesome. It took us 15 hours to do that. Nonetheless, we did. Okay. Longest increasing subsequence. So given an array of nums, return the length of the longest strictly increasing subsequence. So this is a very famous problem. Another, I think it's a recursion problem or a dynamic problem, something like that. But I know you can do an n log n solution. I have done it in n square solution, and I think this makes more sense because here you have 2500, so n square solution work from, right? N square solution work from. But I suppose if you're looking at a very proper solution, it has to be an n log n solution, if I'm not wrong. Yeah. So can you come up with an algorithm that runs an n log n solution? So actually it's a good way to learn the n log n solution now, because I have never come across it. I heard something about stacking and all that, but it didn't make sense to me where I can say, okay, I can actually try and solve this. But let's think through first by ourselves. Okay, let's think through by ourselves first. So you have this, and looking at an n log n solution would simply mean that you go over every element and try to come up with a binary search, because you definitely cannot do a sorting of this thing, right? That would just mess up the order, I believe. So you cannot do a sorting. So you have to come up with some sort of a binary search, in my opinion, right? So here, what you can do is, let's go with a very naive solution. So you can have a buffer and you can keep accumulating stuff, saying, okay, I have 10 in the first place, so the buffer is empty, so I can take up 10. So I would be taking up 10 in the first place, and I would say, okay, the next solution that I can take up is 18, like 101. So as and when you go through it, you would look at, so for every position you have two options. You can not take the number, or you can take the number. If you're going to take the number, it has to be either that your buffer is empty at all, so you're taking up the first number, so it's the first number of your sequence, so that is the only time that you can pick it up. The second thing you can pick up the number is when the previous number in your buffer is smaller, strictly smaller, because it's just strictly increasing, right? So that would give you an opportunity to pick up that number. Or the third one is, I guess that's the only two things, right? So the first part is here, we do not pick, right? So that's a simple one where we do not pick it up. But if we do pick it up, I believe there are two different things in here that can be taken care of. So the first one is like these are conditions, these are not options. So these are conditions. The first option is that buffer is empty, right? And then the second one is I guess we can say top of the buffer is smaller than current, right? So that I think is a solution in here. The problem here is that first of all, we would of course go for an 2 to the power n solution, because we would recurse and try in every possible solution, right? So at every place you would have two different ways to tackle it. So on an average, I believe it would be 2 to the power. There is again, I think, called decision tree, something like that, which basically tells you exactly what is the time complexity for a recursive solution. But yeah, in here, I guess like on an average, it's usually 2 to the power. So I'm just calling it out of my ass, but it might not be exactly correct. But anyways, nonetheless, there's already a problem where you have 2 to the power n solution. So you can always use caching, which usually people say DP, and I call it cache because it makes more sense, and it's actually a cache used for memorization. So if you use a cache, it might come down to an n-square solution. It will generally come down to an n-square solution. There is again maths behind it. I am not that good with it, so I cannot prove how it comes down to n-square. But for most of the cases, it usually comes down to n-square solutions, okay? Again, maybe someday I'll explore how the math works and all that. But yeah, I am not very sure right now. But usually if you have a 2n solution, you use a cache, it comes down to an, n-square order. But saying that, that is a good enough solution for this, I believe, because it's only 2500, so it's not big of an issue. But the only problem here is that I see is that you would be using a space, right? You would be using extra space because you would have a list, and then you would expand and contract the buffer. One of the things I personally believe what we can do is we can just manage the buffer by ourselves, which means that we do not let it grow by itself. So we can pre-allocate a buffer of this entire size, right? You can pre-allocate the buffer of its entire size and put in a cursor we can move around. There are two things. One, you're bringing in a little bit of more complexity, which also means that this top of the stack the top of the buffer has to be moved around. It's basically becomes a stack, right? So you have to move it around with your function. You have to move it with your input function, and that also becomes one of the input to your function, which means that also needs to be part of your key from memorization, right? So that is kind of another problem. So the best possible way here is that, why don't I just take a variable and keep a reference of whatever is the previous number that I selected? Okay, whatever is the previous number that I selected. But the question here is, how do I even know I selected a number? Because I passed down a variable saying what is the previous number that I selected, so if I say 2 is the last number I selected, for 5, 3, 7, everywhere I go down to those recursion paths, I can say, oh, I can pick it up because before this I picked up 2. But how do I know? So let's say one of the sequence starts from 2, right? When I have to pick 2, how do I know that the sequence is empty, right? The sequence is empty. How do I know that? So for that purpose alone, you have to again introduce another variable, which is kind of true false, saying if the array is empty or if the array is not empty, right? So yeah, it brings a little bit of complexities in here. So that kind of gives you a solution of 2 n square without any extra space. Again, looking at the count here, an extra space is really not that much of an issue, but you have to take into consideration that you'll be using memorization, so your cache will also be taking up a little bit of space, right? So saying that, I guess let's code up the solution and see if it works fine. Let's have a working solution first and then try and move towards a more long list increasing sub sequence. Okay, cool. So yeah, again the length starts from 1, so I'm just gonna say if nums is null or nums dot length is 0, throw new value. Now again, someone might say that why you do this stuff. I don't do it always. If I have to put in a lot more thought that what are the edge cases possible for your invalid input, I do not do it. But for most cases, I just do it because that is how you would write in a production algorithm, right? You would never remove your edge cases. So that's just a habit that I picked up. That's all. That's just a habit I picked up. Okay, cool. So where is my diagram? So in here, what you do is you do a recursion. And one of the things that you actually talk about is saying, okay, let's actually do this. Private. Okay. And then int length of this thing. So you have to definitely get an index. Then you also have to get previous number and int boolean empty. I guess one of the things we can do here is that, well, since it talks about -10 to the power 4, we can probably say that, hey, your okay. So you can probably say that the previous number is 10.4 -1, which is kind of, I don't want to do that. I mean, sorry, integer minimum, because that would never be the guy to match with. But then again, it's very specific to the constants given. I don't think I want to do that. I still want to use this part here. Yeah, I still want to use this. Anyways, okay. So now what do we do? If index equals nums dot length, so if you have reached, you cannot do anything, which means you cannot, generate any more sequences. So this is do not pick path. So you can simply copy paste this. So you have nums, you have index plus 1, previous number remains the same, empty remains the same. So int length 1, I would say. Okay. Now, if empty or previous number, so we can say current number, nums of index is greater than this. If it's either one of them, this is when we can say, okay, this becomes the previous number. This becomes a previous number for this, and we can hardcode false here. So this would work in both cases, whether it was empty, now it's not. And if in case your previous values were like, if it was empty, you had to swap it. If it was not, you anyways had to pass in false. So we can hardcode false in here, and in here we are adding 1, so this would be it. So we can do something like int length, so max, because we're trying to find a maximum. Well, have to reassign it back, and that's it. That is it basically. In here, let's call the function 0. Previous number can literally be anything, it doesn't matter, and true. Yeah, and you can return this. As far as I know, this should be working. This should be working. This should be. So class solution. Yeah, this works, but it's gonna fail with your uh, fail with bigger, yeah, time limit exceeded. That's what I was looking for, because the bigger the number, it actually went to 2 to the power n. Let's actually see if I was right. Yeah, my assumption was right. It's gonna be 2 to the power n, but usually you shouldn't be assuming. You should be creating the tree. And yeah, there's a good video on Geek for Geeks and a lot of other videos. Maybe you can check out how to actually do that. But in here, now the problem is we have to add, well, here, let me pick the number, right? So in here, we have to add the cache, right? And so in here, there are 3 things which are changing: index, previous number, and empty. So we have to cache all of those. So I'm just gonna bring in a key here. So since I cannot define a tuple and all that in here, I have to go with the object. I cannot even do structs in Java, so I'm just going to do that, right? So private record pair, or I'm just going to call it key. So int index, int number, boolean empty. Okay. So right here, we should be equal to new key. So it has to be index, previous number, and empty. And we need a cache, which is map of key to integer cache. If cache dot contains the key, you can simply return cache dot get for that key, right? And if not, put key and the length, and you can return that. So you have to pass in the key here, the cache, sorry, pass in the cache here, and also you have to pass in the cache here. And you don't have any use, so we can lose the reference in here. We don't have any use of the cache after this is done. And I have to change this class solution, and if I'm not wrong, this should actually work where it comes down to n square. We can actually analyze again the complexity and see, okay, this also didn't work. Wow, why is that? Huh? Wait a second. This is still giving to the power n. Okay, this is n square, but it still didn't work. That is very weird. It still didn't work with 2 to the power n. I believe it worked for 2 to the power n, right? Okay, let me submit one more time, but it's definitely not going to work. It failed at 22, which is quite, it's not even half it, right? It's not even half it through. So that is pretty sus. I thought I did this same problem before and it passed. One of the things why it might not pass is because your boxing and unboxing takes a lot of time. So we can try to change the cache and see exactly what happens. For that, I'm gonna say this is 0, and if empty equals 0 or this thing, I'm gonna pass this, right? So yeah, I'm anyways gonna remove this part. So what I'm gonna do in here is cache. Again, I'm not sure if it's gonna work, but let's see. So cache of index, previous number, empty. Again, we have to do an integer here because we have to check this. Return cache of index, previous number, and empty. In here, equal to length. Okay, so we gotta change this stuff in here. Cache new integer. There's a problem in here. Can't even tell me what the problem is. It's gonna fail very badly. It's gonna fail very badly. Why? Why is it gonna fail very badly? Because I'm using previous number as one of the indexes, and previous number can be negative. So that's where it's gonna fail. So we cannot be doing that. We cannot be doing that. So let's think through and try and debug exactly why this doesn't work. I'm gonna copy this again. Yeah, so even though it's an n-squared solution, it's an n-squared solution, and it's this much. It's not a huge number. It's 6.25 million, right? 1, 2, 3. Yeah, I guess it's 6.25 million if I'm not 62 million. Sorry. Yeah, I mean that can be slow. I think can be slow, but usually for an n-squared solution, it's up to 10 to the power something, right? Time complexity constraints. This thing, yeah. So I like to again refer this particular thing if somebody is interested. If somebody is interested, it can be slow, but usually for an n-squared solution, it's up. This is something that I follow. It's something that I follow. So in here, sorry for flashbanging. Okay, so here it says that if n is less than 10.4, you can still go with an n-squared solution. Okay. But yeah, let's try to figure out why this didn't work. I'm assuming it didn't work because of the fact that you have a cat which always works at object level, so you have a bit of unboxing and boxing, right? So that is the problem in here, I believe. That is a bit of the problem in here, I believe. Okay. Okay, let's see what's exactly happening. But now we have to come up with a solution which is n log n. I believe that's the only way. That's can you come up with an algorithm? I mean, this is sorry for that. I hope that was not too loud. Still not sure. Still not sure. So how can we come? So you have, I believe it has to be a binary search. It cannot be anything else because how else can I do n log? You can start with 10. And there is 9, which is smaller, so you cannot have something. But I cannot quickly evict 10 and you cannot quickly evict 10 and put in 9. Right? You cannot quickly do that. Okay, the first thing I want to look at is previous submissions because I remember I did this problem. And okay, actually for Java, everything was time limited exception before. Okay. So I guess I never solved it in this way. But I think I solved the same problem in a different in a different platform in the same way, I think. Yeah, I suppose. Hmm. But in Python it works fine because I guess I used a tuple. I definitely use a tuple. Analyze complexity. It has to be n squared. It is in log n. Okay, so this has to be okay. I forgot how I solved it. I completely forgot how I solved it. Yeah. Okay. So let's think a little bit before I actually start giving it and looking at the solution, right? So in log n has to be some sort of a binary search because sorting doesn't help here. You lose the order. Binary search here can tell you that what is the next possible number that you can pick up. What's the next possible number that you can pick up? But the problem here is, so let's say you have 10 in here, you have 12 in here, you have 11 in here. If you pick up 11, it can be possible that you're losing out on 13, 14, 15. No, you will not, right? You will not because you still pick those up. That is not the problem. Okay, never mind. So that's not the problem. So we can just pick up whoever is the next smallest to, like a next greater number to 10. We can do that. And for that also you can generally use a stack. Cool, I'm not gonna waste time. I'm actually gonna peek into the solution that I did before and see exactly how I solved it. We need to, okay, we need to find the index of an element greater than equal to target. But why is it equal to the target? Okay. So if the length of the subsequence is this, you append the number and you move forward. If the number is greater, you just append. If it's less, you try to find the index greater than that number. Okay. And subsequence index is none. So what is index exactly? So, okay. Wait, what? You find the index greater than that number. So you have, that's weird. You're still doing a binary search. Still doing a binary search where you're saying that the subsequence of the mid is greater than equal to the target. Okay. You're trying to find out. Okay, I was going in the wrong way. I was going in the wrong direction. Okay, cool. I get it now. That's a different way of thinking, and that's a different way of approaching a problem, I would say. And that actually helps a lot of times. So instead of, because I was looking at number 10 and I was saying, who is the next element that I can fix after 10? Instead of saying that, we're going to pick an element and we're going to say, so it has to be a subarray. So we have to create the subarray, right? We have to, a subsequence, we have to create a buffer. So the buffer is empty, we say 10, I'll push 10 into it. Then you say 9, so it's smaller. So I'll try to find the index where I can fit 9. And I'm going to remove this part. Because as I fit in more smaller items, I think I can actually do this thing. Why are you crying? Oh, what? So what you have to do is you have to take this entire streak of it. You say 10 it is, and from there you say that I for 9 you try and find where it would fit and it would omit everything else. Is that so? So we just replace that. But what about anything after that? So let's do a dry run. So in here 9 would fit here, so you would say 9 is this, but you're trying to find index greater than. We need to find the index of an we need to find the index for an element greater than or equal to target. So in here it would be -1 because there's nothing greater than or equal to 9. There's nothing greater than or equal to 9, right? If that is correct understanding. So it goes somewhere here. So you try and find this, the target is 9. So you pass in the 9 as the target. So you're saying that if the mid is greater, if the mid is greater, you take that. Okay. So in here it would be -1. In here it would be -1. And without even thinking, we put this like this. Which is kind of a dangerous thing to do in Java because -1 would fail. So here it makes sense to do that. But let's say it comes in the last. So this would be the last. So now it's 2 again, it would become this. Now it's 5. So the index where the element is greater than this. Sorry, this is where, okay, so you're replacing 9. But in here I'm interested how it's gonna work. I think I'm gonna want to actually look at this, how it is working. So in here, what I do want to do is print the index. So s equals solution s dot length of lis. Let's give it this guy. Okay. 0013. I think I want a little bit more stuff in here. So you always say nums, and then you say num, and let's also give in the current index. Enumerate. So maybe a sequence also, right? Slowly I'm increasing. So maybe we do it like this. Nums is this, and then is it not how you write it? I guess I have to put this in to make it work. Is that how you do it? Yeah. So in here, I also want to say subsequence is equal to the subsequence. And num is equal to a number, and index is equal to index itself. Subsequence. Okay. So now you have this. So when you come to 9, you say that the index is 0. And since the index is 0, you're going to replace the element at index 0. Okay. Now you're going to say nums is 2. So again index 0. Okay. Now this is index 1. Aha, this is why it never faced any issue. Okay. So you have 5. After 5, you came across 3, which is again less, so your 3 replace this. So as and when you have anything bigger, you keep on appending stuff. But if you have anything smaller, you replace it with the right next element who's greater than that. Yeah. Okay. Um, Moving on, I think how we do have to do that in Java is okay. Okay. Sub sequence. So length has to, why can't you just int length equals nums length, or int I equals 0, I less than length plus plus. Okay. And cursor is 0. If cursor is 0, or subsequence of cursor, so let's say the current element is nothing but this int. So if the current element is greater than this, we simply say target. Else, first we have to find a target. So index will find index of next greater element. So you have to pass in the subsequence. You have to pass in the cursor, which is the length till what you have to do the check, and then you also have to pass this thing. Right. So this is private int. So then you have this, then you have this. Okay. So int left is 0, right is cursor, which is inclusive, and while left is this thing in here, and int index is -1, and then you can simply say mid is left plus right minus left by 2. Anyone knows why we do this? Not simply left plus right by 2 and we do this part. It's a very interesting thing where Java actually did it wrong for a couple of years, like a couple of years in the sense a lot, many years, and I think recently it got fixed. But yeah, it's a very interesting story. I mean, it's a very subtle issue. But anyways, so what we have to do is if subsequence, so let's name this as array. If array of the mid is greater than or equal to current element. So this is one of the possible index that we have to capture. And since it's already bigger, we want to look at the right next part. So we might have something better on the left hand side. So we eliminate everything on the right and we say right is this. Else left is mid plus. If I'm not wrong, this is correct. Okay. And what we do is subsequence of index shall become the current. And in here, cursor plus 1 becomes the left. What you're cribbing about, yeah, I mean, you can always do that, but yeah, this is basically it. So important thing about notes is that I already solved. Okay, it's the wrong answer. Awesome, it's the wrong answer. Why is it the wrong answer? So we have to find a greater element next to this. So if I look at our previous solution, if you look at our previous solution in here, yeah. Okay. Wait a second. No, I did this right. I did this right. Okay. So length is left is that thing is not. So if you're looking for the next greater element. So this is right. It's not wrong. Oh, wait. We have to reset the cursor here. That's the problem. Because yeah, that's basically the problem, I believe. So it has to be +1 because the cursor is always one step ahead, and the answer cannot be +1. Answer has to be this because we started with 0. My bad. Still wrong. It still says 8, which is not the case. Doesn't have to be just index, but why? Yeah, that is wrong. That's wrong. That is wrong. So you take the index and you put in current in here, and then the next element that should go is index +1. So what am I missing in here? System out print ln index. If you look at that, wait, what? It never went here. If the cursor is 0 or the current is greater than subsequence of the cursor itself, so now you say that subsequence cursor plus plus is equal to current. Okay, and that is true because in here kind of do the same thing. All right, so if it's empty, its cursor is 0, or the number itself is greater than whatever was last one was. That's why. Okay, another bug. It still doesn't work, but at least now it works fine here. So this was one of the bugs because you always look at -1. So cursor is 0. You will never hit this part. It would fall through. It would be like a short circuit, and yeah, okay. The next question here is why is this not working? Because in here clearly we would be getting the indexes as 0, 0, 1. So you have to have 3 indexes. Do I have to do this index? Which I don't think you have to. That is wrong again. You have to do +1 because it's always 1 ahead. So you're resetting the cursor in here. Okay. And this is this. This is this. X +1. Cursor. Okay. Yeah. Hmm. Okay. Now I'm very confused what I'm doing wrong. Just a second. I'm messing up something in here. It just feel. Wait. Okay, yeah, that's correct. I mean, we can always rename it to no, but that is nonetheless not the problem. Cursor is always the len. Current is always the number that you're passing through. So if your array of mid is greater than equal to current, which means this particular element is greater than the current, which means that okay, this is one of the potential answers to your solution. So you save that index, and then you say okay, nothing on the right hand side, it's only going to be bigger, but I do want the smallest greater number, right? So I'm going to elevate everything on the right hand side and remove this pointer here. If not, you always move the point to the right. And you're always going to find an answer because of the fact that you're in that particular else if loop, right? You're at that loop. That is honestly pretty sus. Why it didn't work? What I do want to do is index would be this and current would be this. I wish there was an easier formatting thing in here, but okay. What just happened this time? Wait, this was always working. This was not. Okay, my bad. This was not working. We have to do this, but why? That is not the right thing. It's strictly increasing, right? It's strictly increasing, so we cannot do that because in here your answer would be 3, which is also wrong because if this is this, then every one of the output should be. Oh yeah, I was looking at the wrong stuff. Okay, so this is not correct. So this was always right. In here you're getting 4, you're getting 3, even though you're expecting. So it has to be 0, 1, 2, 3. Because you have 0, then you have 1. The problem here is when you have 0, it would say this is 1 and it would replace itself. It would replace itself. And one of the things we can do is this. If array of mid is equal to current, I'm gonna return -1. Else if I'm gonna do that, well, I have to remove this. In here, I'm gonna have to say if index is -1, I can simply continue because I know that the number is already there in the stack itself. I broke something. No, I didn't. Okay, I guess this is taking a lot of time, so let's remove that. Let's remove that. Let's go back and submit and see. It didn't work. Awesome. So let's make the changes first. Okay. So I think it's time to look at the editorial. Dynamic problem and all of that. We did this thing. The difficult part of this problem is deciding if an element is worth using or not. Consider the change. Okay. Improve with binary search. In the previous approach, when we have an element num that is not greater than all the elements, we perform a linear search to find the first element in the subsequence that is greater than or equal to the sum. Since sub is in sorted order, we can use a binary search instead to improve efficiency. Okay, so I guess we have to look through this particular solution first. As stated in the previous, the difficult part of the problem is at first the element 8 we might have speak is since better than nothing, so subsequence equals 8. And the second element, we cannot increase the length of the subsequence since 8 is greater than equal to 1. So we have to choose only one element to keep. Well, this is an easy decision. Let's take 1 since there may be elements later that are greater than 1. Yeah, exactly what I was saying, but less than 8. Now we have sub equals 1. And we do not lose on the length because we are removing one element and we're bringing in one element. So we'll never lose that element, and if anything greater than 8 can be placed in a subsequence, if I replaced 8 with something smaller than 8, I can still make the subsequence. That is the entire intuition, I believe. That is what the entire intuition is. Okay. So at the third element 6 will blah 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 and all of that. That is fine. My intuition is correct. Only thing is I have some issue with my code, which I don't know what. The algorithm doesn't always generate a valid subsequence of the input, but the length of the subsequence will always be equal to the length of the longest increasing subsequence. For example, with the input this thing, at the end we'll have the which is the subsequence, but the length is still correct. The length remains correct because the length only changes when a new element is larger than any element in the subsequence. In that case, the element, are you saying, but no, it still have to, because I just cannot return back length, right? I just cannot return back length and be happy with it, my opinion. Okay. Let's look at the Java solution, what they are doing. Let's look at right away this particular solution. Okay, so you have a binary search. If this is equal to num, you return mid, else. So I don't like the solution. I immediately don't like the solution. The reason why I don't like the solution is because it takes into like this less than and like what kind of option you have to break and all that. So I feel my solution is more easy to understand solution. If it's greater than equal to, it's a good answer, but it's one of the possible answers. You can have a better answer on the left, so you just move your pointer. Anyways, if this is greater than the last element, yeah, I don't want to do this because it keeps on increasing and decreasing. Wait. Yeah, everything here, what I feel what I'm doing is correct, except the fact that not sure. Sorry. Okay. This would be this. This would be this. So let's rename some of the stuffs first. This would be none. Well, not none. This would be num. And here also, we can call it target. Why is it? Renaming current is not finished yet. Finish करना भाई. I don't know what it wants from me. Target. Target. Yeah. That is, I guess, what I have to look for. Okay. Then in here, what we can do is where is my so you always add on to that now. Sorry. So what do they say in here? You always add the first value no matter what, okay? And then you start from here. So let's replace with an index loop and this. So subsequence of 0 should always be nums of 0. So then you don't have to put this check ever. And this is, I still have doubt that this is gonna work because it's essentially whatever I wrote before, just without that cursor is 0 condition. Yeah. The big problem here is, why is it saying as 8? I also reset my cursor. I also do reset my cursor, but what is the issue here? So let's look at our Python code. This is exactly a copy of whatever we have in Java. It's basically a copy of that. Wait a second. Wait a second. But that has to be wrong, because the cursor is always one ahead. That was anyways wrong. Okay. So now, wherever your index is, take the index. Why would you not reset the cursor? They're not resetting the cursor here, right? Why would you not reset the cursor here? Some of the things we can do is this, but it's nonetheless not related to the problem. So whenever you replace this number, you say the cursor has to be the next one, because that has to become fair. And yeah, my bad. I have to do that. I forgot. So is that what was missing? That is still not it, right? So still have missing in here, which is when both the numbers are same. So that is when you fuck up a little bit. Okay. I'm just gonna ask a question to ChatGPT. That is wrong. Also in here you have to do this. It doesn't have to be do that equal to. No, right? Yeah. Constructed, but there's no small cursor is index +1. This line is wrong when you're replacing. That line is wrong when you're replacing an element, not extending the subsequence. Here's why. You're always doing index +1, even when you're replacing an element in the middle to maintain a smaller tail. That messes up the length tracking. Example, if 08412 comes up, expected alias length is 3, which is 0412. Your code overwrite cursor during replacement ends up undercounting or misplacing the next element. That I know. But why don't I need to change the... Subsequence doesn't build the actual subsequence. It just tracks ends to compute length efficiently. Okay. I'm still not getting it. So if you're telling me if I just remove this, it's all gonna be hunky-dory. Okay. Why? So you find a number and you say where exactly is the next greater element, and you remove that part and you push it in there. The cursor is always pointing to the end of the array where you're pushing in all this, right? So there might be numbers which came in before this particular element, which are greater than. So it was like 1, 3, 4, 5. So 2 came in, 2 replaced 3. But the subsequence now should be 1, 2. It shouldn't be. The entire question is how do you keep replacing? Okay, I'm still not getting it, honestly. I'm still not getting it. Okay, I guess I have to do a little bit more research on this one because I still didn't get it. I have no idea how I solved this before. But yeah, this is one of the things that we have to look into. Cool. I'm not gonna mark it. I'm not gonna mark it. Did I actually submit? Okay. Longest sub increasing. Okay, let's go here and let's mark the problem for later. I think there was a way to bookmark it, right? There was a way to bookmark it, I believe. Like this, I see. Wait. I solved the problem before in 40 seconds. Which is sus. Okay, I solved it here. How did I do that? As a straight up and solution. Okay. Straight up and solution. Okay. Yeah. Okay. Okay. Cool. Okay. Let's pick one. Rotate image. You are given an n cross n 2D matrix representing an image by rotation. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. So rotation of this image is quite easy, where you have to what is it called? Matrix transpose, and you have to then swap things out, because if you do a transpose, as you can see here, this 147 will come in the rows, and then you just have to revert it. So that is how it's done. And since you're doing it in place, you can always go from like 0 to 1, and then you start from row number till the end of it. That is usually how to do it. Okay, so let's do that. Rotate image. I'm not gonna put a comment on this because I need to revisit this shit. Yeah. Okay. So let's quickly roll just matrix length. Columns is this. For so intro is 0, row it's less than rows, row plus plus. For in column is row column list columns plus plus. We simply have to do matrix of row and column will be equal to matrix of column and row. And this is only possible because it's an n cross n matrix, okay? Otherwise you cannot do a transpose. You have to create a new one. But yeah, anyways, after that, for again every row that you have, int left is 0, right is false -1, while left is this. You can simply say matrix of row left equals matrix of row right. I think arrays.swap, it's not there. I believe it's collections.swap. Okay, so this is gone. So this is this, and matrix of row and right should be equal to 10. Remove the left pointer, remove the right pointer. That's all. Right. Yeah. And we don't have to do anything because it's an in-place algorithm. Cool. This is a solution, and this should be working fine. Saw this quite many number of times, and hopefully this will. Let's see. And it didn't work. Why it didn't work? Wait a second. Why didn't it work? What did I do wrong? Because we didn't transpose it correctly. I'm getting a bit tired, honestly. Okay, so this can be equal to this, and this can be equal to this. If here, let's call it 10. Yeah. I want to remove the dark mode because it looks very bad. Okay, this is better. What happens for different row count and column count? Hey Shantanu, how's it going with you? For different row count and column count, it will not work because, okay, if you look at the problem here, it simply says n cross n matrix. And looking at the pattern, we can see if you do a transpose, you can get the solution. But if it's not a, like if the rows and columns are not same, you cannot do an in-memory, in-place transpose, right? Because if you have like this, right? If you have like this, your transpose matrix would look like this. So where this would go here, this would go here, this would go here, right? So if you have an n cross m matrix, the in place will not work. You can still make it work with like whatever algorithm is given here, but since it's mentioned in place, you can only do it in place because the transpose, because you're doing it in this way. Otherwise, your algorithm would have to take into account a little bit where you create a new memory and you then do the swaps. Okay, that's basically how you do it when you do not have any like you do not have rows not equal to columns. Okay, basically that is how to do the transpose. I hope that explains a bit. And hello, welcome to the stream. How's it going? How is it going? Okay, uh, let's continue and see if we can solve two more problems because, well, this is ChatGPT. Oh, I have to ask it to give me notes. Give me notes, please. LeetCode problem set. Okay, got it. Thanks. Again, I have to do some filters stuff. Okay. Status is not completed. I really wanted to do a simple problem, but I don't think anything left is easy. Oh, there are a couple of easy left. I may be doing that because I want to get 2 or 3 done so that, you know, it boosts the confidence saying, okay, I can get things done. Going great. Oh, awesome. Welcome to the stream. Thanks for joining. Okay, so number of islands. This is also another solved problem. Again, I solved it before. Again, I think the Blind75, this is the third time I'm solving it. It's a good exercise for your intuition building and all of that, I would say. But anyways, given an m cross n matrix, and here we have a matrix where your rows and columns are different by a binary grid where a map of ones and zeros return a number of islands. An island is surrounded by water and it's formed by connecting edges and lands horizontally or vertically. You may assume all 4 edges of the grid are surrounded by water. Okay, so what exactly this problem statement says, right? So you have this grid, right? Let's just say this is the matrix, right? You have this grid and one is okay, anyways, so here you have okay, 1 is land, 0 is water, and it is assumed that, you know, the outer edges of the matrix is also water. Okay, so what is an island? A piece of land which has water on all the sides is an island. Okay, and how you're going to do this is, so this they are connected, right? So this is again connected to this is again connected to this is connected to this is connected to this. So all of these together will be forming an island. I hope that is all that is. Yes, so this is what the island is, because here there is water, here there is water, here there's water, and, you know, the other sides are water on the land mass that we are getting. So this is one of the islands, and we don't have another island in here, so there's only one island. Okay, but if you look at this, there is 3, so let's try and find all 3 of those. Okay, let's try and find all 3 of those. So in here, yeah, this is clearly one of the islands. Okay, so there is one more one in here which doesn't have anything associated with it, and we have to take into account it's only horizontally or vertically, right? So it's only, so I think it's called damn it, I don't know what it's called. Cellular automata. What is the most famous cellular automata? Game of Life. Neighbors. How to count? Not count. There's a specific name for it. Called. Not interested. Mood neighborhood. Yeah. So it's not completely mood neighborhood. Mood neighborhood is basically all the 8 surrounding cells, including the diagonal. Sorry. But here, I don't know, you can call it half mood, because if you take this particular cell, then this, and this is what we basically consider as the neighbor. Okay, so this here is a mass of land which doesn't have anything, you know, attached, so you leave that. And this here is another one, so this has this attached, or you can consider this and then this attached. It doesn't really matter which one you consider. Is just that if it's adjacent and if it's connected, you basically consider it as a single island, right? Basically consider it as a single island. So now the answer is 3, and this is what we see in here. Where is this guy? This is what we see in here, right? This is what we see in here. Yeah. Question is how we do this. Well, one of the solutions that I generally do is thinking of it as a graph. So you can do a BFS. So whenever you find a land, you try and, expand your reach from there, and you see that if you can, accumulate more land. Let's just say that you are a king here, and you try to accumulate more land around you, but only in the 4 directions that you're allowed to go. Okay, so if I am here, I would try to go here, here. This side you cannot go because this is out of bounds, and on this side you will go. But here, once you try and go, you find this, so you acquire this land. So let's say this is one land now. So from here you try and go to different places, and yeah, if you could go here, you would acquire this land. So this is one of the things that you can do. So this is a general solution to it, and basically what you start doing is you iterate from here. How I like to do is you start iterating from this guy. I mean 0 0. You start iterating from here, and then whenever you find 1, you start grabbing more land from there, right? You start grabbing more land from there. Only thing you have to take care of is you do not go back, because once you're here, so let's say from here you jumped here. For this guy, the neighbor is left side, which is not there. On the right side, you will go and explore. This down, you go and explore, but it's also on the top. So here you would be going back to something you already visited. It would not make sense. It would not make sense, right? So if you have gone on an expedition to acquire more land, you will not come back like down the path that you went through. You would explore more land, right? So the way I usually like to do it is, so it is okay to keep a set. You can track the visited cells in a set, but that is more memory consumption. So what I like to do I like to change the values in the matrix itself. Okay, so I would take a value which is not there. So I know 0 and 1 is there as a representation, so I would just mark it as 2. I'll exactly tell you why I mark it as 2. So now if I change this as 2, I would only go to my neighbors if they are 1. So here I would never come back because this value has changed to 2 when I'm here, right? But now the question can be, so this eliminates the problem of if I like, how do I track where I need to come back or not, right? It basically eliminates the possibility of that. But now the question comes is that we are mutating the input array, the input. Okay, so it doesn't quite say that you can import that you can mutate it, which kind of means that you should not mutate. Let's just think in this way. Even for programming, basically whenever you give me a ref, usually if I'm not wrong with C#, it clearly says it's a ref value, which means that I'm asking it to change it or something like that. I may be completely wrong. I'm not a C# guy, but I saw something similar to that in C#. But if you pass it by like an array or something, it's usually not a good practice that you actually mutate the values, right? It's not a great practice. So the question here is, oh, we dropped quite a bit of frames. 987 frames we have dropped, but okay. So basically the question here is that how do we fix that, right? How do we fix that? For fixing that, what I usually do is, it doesn't cost a lot to, iterate over the array one more time. Again, it's a classic trade-off. So I could have taken a set and not iterate over the input array again. But here I am not, I'm saving a little bit of space and I'm iterating over it, iterating over the input. So if I'm asked that, hey, can you not trade off space and we need a little bit more speed once you do run the algorithm actually in production and see that, oh, you benchmarked it like this. And if I figure out this is what the bottleneck is, like it's taking a little bit of time just again to iterate the same array to, convert all the 2s into 1s. It's a very simple solution to just start with the set and see what exactly happened. If not, we can go into some other details. Okay. That is basically what the solution is. Not counting same land multiple times. Yes, exactly. So we need a way to do it. In Java, you have the way where you can use a set, but I don't want to use it because it's memory heavy. So what I'm going to do here is that I'm going to just change the value, but then people usually do not want to change some input. It's usually better to have pure functions, so it doesn't change the input. So I'm going to rechange the input again. And taking into consideration that can also have some problems where you have that can also have implications if you have concurrent solutions, because then you are changing. But then yeah, here the problem is a single threaded problem, so you don't have to think much about that, right? So that is what we are doing. Okay, I guess let's code it. Before that, I think I asked it to, okay, yeah, so transpose matrix reverse each row. I can just say this thing in here. So this is my revision note. Transpose the matrix reverse each this thing. Time is this, in place rotation of n cross n. Yeah, that is correct. That is correct. Okay, so number of islands. Cool. Let's do number of islands. I hope my explanation is good enough. But yeah, let's do it. So rows is grid dot length. Columns is this thing. Again, in production, you would not be writing this code directly, because what if this is a null pointer, right? So you should be having all the checks before you start working with that. So here I'm not putting it because I'm pretty sure somewhere here they said, yeah, it's gonna be less than equal to 1, so greater than equal to 1. So I'm not putting the check, but usually in a production code you have to put in certain checks here. Anyways, let's go through it. So basically what you need is for BFS you would need a queue. So it's a deck in Java. So you need the, like, let's just say row column. Okay, so let's also do one thing. So let's say private cell next and int direction return new cell this dot row plus x direction of 0 this column plus direction of 1. Okay, and sorry, not private. Then here you can say boolean in range. I like to do another one of these rows in columns. So return row is greater than equal to 0, row less than rows, and column greater than. Okay, bye bye. Bye bye. Good night. Hello. Thanks for dropping by. Bye. Okay, column greater than equal 0 and column less than columns. Yeah, that's pretty much it. So here pair, because it's called a cell, q is new array deck for int row is 0, row less than rows, row plus plus. Here columns. Okay, so now what do you do? If grid of row column not equal to 1, so I'm just gonna return. Well, I'm just gonna continue. Okay, just gonna continue. If so, we need to do something. Q dot not append. I think it's called offer. New cell of row column. Okay. Grid of, we can copy paste this, but we can probably write it is Q. So we mark it visible. int islands is 0, islands plus plus. So here you have visited an island, right? Here you have visited an island. So let's say this is where I first landed. Now what I'm gonna do is I'm gonna go to every adjacent landmass and I'm gonna mark it acquired, so that next time when the loop goes through, it would say that I don't need to take care of those because it's already been visited when I visited the first one, right? That's what the entire goal is. That's what the entire goal is. Just gonna quickly Okay, I am back again. Let me just do it out. Okay. Yeah, without this, my voice is not working today. I have to check the settings. I'll remove the headphones because it keeps on looping on my ear, which is irritating. Yeah, cool. So I'm back, and yeah, the solution works. Let's quickly ask ChatGPT for a revision note. So we did 3 problems, which is good. Which is good. Let's pick one more and see if we can finish it. So we'll be streaming. I'm streaming for almost 2 hours now. Probably streaming for 15-20 minutes more before going off. Yeah, cool. Okay, so longest repeating character replacement. Hmm. You're given a string s and an integer k. You can choose any character on the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter after you can perform the same above operations. Okay, cool. So here the question basically is that this is the given input, this is the given input, and if you take a and if you start moving, there is, so k is what? K is 2, so you can replace at most 2 characters, right? So if you go to b, it's a different character than a, but I can say, oh, replace it. So we can say, oh, it's a now, right? It's a now, so we replace that. Then you come to a again, so which is again the same because you have a, right? And you come back to b, you say, oh, you still have one left, so you replace this guy, right? So this is how this is where you can say that, okay, the maximum length that you can generate is 4. If you have this thing, you can only replace one, so a b a b, so this is, I guess, the place that you replace one of those, the b, and this is where you can get this. Or you can also talk of b a b b, and you can replace one of the a's, and this is where you get a maximum length of 4. So it's 10.5, which means you can go up to n log n, if I'm not wrong, for this kind of solution. So usually you have to now start, because the first solution which comes to your head is, why don't I just try and generate all the substrings and try and figure out if the mismatched number of characters is k, right? That is what you can do, but that would be an n-square solution, which won't fit into our problem statement here, the constants given, right? So we have to look into n solution. So you go here, then you come back in here. The question here is, how do I move the substring, the left and right? It's in here, right? So this is a b a b. So in here, if I look at this, and here I have to move here, and I say k is 2, so it's good. So k should be 1, and I should be moving forward. In here again, everything is good because it's k, and I move here, so k is 0 now. Well, if there was something else like this, you could move forward, because when you moved here, k is 0. So this is where you have to stop. But now the question comes that you came here and it's a mismatch. You said the maximum length is 4, so you put it, you save the state. But the question is, where do you move this left pointer? Where do you move this left pointer? Right? Hmm. I believe one of the things you can do is you can keep moving this till the point whatever variable you were looking at, whatever character you were looking at is not same, which means k will be back to 1 again. It will be back to 1 again. I feel that's what the solution would be. So in here, you would come here and k would become 1 again, and you would stop. You would stop. But that's not the correct solution because there's already an a in between. There's already an a in between. So even if I move this pointer and say, oh, this is k is 1, so I can change it to b, this is not the correct solution, right? So what is the solution? I think we have to keep moving the pointer till k becomes its initial state, which is 2. I have to extract out everything which I first took into that substring for which this value came down to 0. So it would go back here and it would say, oh, this is again the same variable, so why don't you just move back? So in here, this would become k equals to back again. So from here, you can start going through. And if this was it, it should be 4. Well, let's just do this. So it would be 5 now. So let's see if the solution is what I think it is now. All right. So in here, if I go, if I take this, ABAB, CABB, CABB. So if I return 1 in here, the answer should be 5. The answer is 5. Okay, cool. I think that is what the solution has to be. So what we have to do is temporary should be k. Start is 0 and current is 0 and start is 0. While current is less than the length, you keep on iterating. So let's remove all this stuff in here. Let's remove all the stuff here. So what you have to do is character is start. So you take this character. If ch not equal to s s at current, so we have to take two decisions. If k is 0, we have to do something. Else, you move forward and you say k minus 1. Sorry, I have to do 10. 10. Right? And then, if this is this, the first thing you have to do is length would be current minus 1 minus start plus 1. So it's current minus 1 because this is where you mismatch. C is where you mismatch, so you have to take something from behind, right? Max length, max length, and length. Right. So now in here, else current plus plus. And at the very end, what you can do, so here you have to reset, wait. Here you also have to reset this particular start, right? Have to reset the particular start. While temp not equals k, we have to keep moving forward. We have to keep moving forward. And how do you do that? start plus plus. If s of start is equal to whatever the start character was, we have to say temp plus plus. And now that you have gone through the entire thing, your start already points at the place where it is this, right? Yeah, I think that is for how we have to go about it. That is how I think you have to go about it. Yeah, let's see with the solution if it works. Let's copy this. Well, I forgot to. Yeah, let's actually do this. So BFS flood fill. This is this. So this is my revision note. Cool. This is cool. So let me go back here and copy this. Int temp is k. Int parent is 0. Int start is 0. Again, we are taking into consideration that at least the length is 1. Okay. So then character is s character and start. Why? Current is less than s length. So what do we do? If character is equal to character at this, simply do plus plus. Else, if temp is 0, else can you simply do this thing in here. Okay. So int length should be current -1 minus start plus int max length is max length. So max length is 0. Okay. And because of like this, yeah. Anyways, moving forward. Okay, so you have length is this, you have max length is this. So next, what do? You reset the start index, right? So you say while temp is not equal to k, while temp is not equal to k, you first move this pointer. if s dot character at start is equal to ch, this is where you say temp plus plus. Yeah. And max length, max length is length minus 1 minus start. It has to be plus 1. Turn max length. So I feel this is what the solution has to be. Let's see. String out of bounds exception. Where do you do exception out of bounds? Oh. But start should be less than car. If we do that bounce check, I believe we should be good here. No? Holy shit, it went in the negative side. What are you talking about? How did this go in the other way? Well, we never actually increment this thing. So I believe we don't have to do this in here. I don't think so. Yeah. That is weird. Okay. So while temp is less than k, or you can also do that. How do we do this part? Yeah. Well, I put it in the wrong place. Okay, this is also not gonna work. That is sus. And I feel like it's just timeout in here. It's gonna time out in here, I think. You can actually run it locally. Yeah. Okay, that is fine. So what am I doing wrong? You know what? I think the wrong thing that I'm doing is I am always bound with this character. That is wrong. Instead, what we have to do is we keep an array. Does it say anything about it's only uppercase English? Okay, so we keep an array of 26. So we keep adding stuff. So like frequencies, we keep adding frequencies, right? The moment temp is 0, what we have to do is we have to take into consideration the length of this thing, and it should be okay because it's always 26 characters, so it's of one operation of iterating over that particular array, right? So I think this is wrong. Okay. Int frequency is 26. So int I equals 0, I less than s length, we can simply say current is this. But the question is, how do I find the mismatch? That's the question, right? So if I put everything in an array, so A is 1, B is 1, A is 1, and then A again, because A is now 1, so A again, so this is 3, this is 2. Now we come here, so this will be 2 again, no issues. But then we can simply move those many number of steps, right? But what about the next iteration? I can only move that till the time k becomes 1. The temporary value becomes 1. Temporary value becomes 1, right? So what we can do here is the problem is A, B, A, B, C, A, B, B. So this is A is 1, B is 1. So since it's a mismatch, only one, no, that is not true. That is not true at all. Because if you have A as something, you can have B as something, you can have C as something, you can have any number of these things as long as within this K bound, right? As long as it is within the K bound. So what you can do in here is this is 1 again, so K is now 1. When you go here, this also becomes 2. So K is 0. So you go here and you see you have to so since K is 0 and C is also 0, we have to move the pointer here. Is that not? So then B becomes 2, but this thing becomes 1. So it is B, A, B, C. It really doesn't matter if it's 3 because I can still replace. So it's 1 and K becomes 0 again. Now it's A. So now it is A. Question here is, we really cannot replace this, can we? Because if I take B as one of the elements, so we have 3 things which we have to replace. So the only question here is, how do I figure out that I am replacing 3 and not 2? How do I do that? where is my, so yeah. So you move the pointer to the left. So there has to be some kind of pointer here which you have to move, is what I feel. Your left pointer is here. Your right pointer is here. Here. So here, honestly, I have to move the pointer. How do I know I have to move the pointer here? Because k is 0 and I go to a value is already present as 1. So this is 1, this is 2, this is again. We know for a fact that we have to move it because k is 0 and you have 3 elements here. There is not a chance. No, there is still a chance, right? It could have been like this. Suppose let's look at the intuition. Does it have hints or something? It doesn't have hints. And I don't think I solved this. I solved this problem before. Okay, let's actually look at the solution. Let's look at the analysis. It's O of n. Okay, it's O of n. And what we did here, okay, we did frequency, we did start and current. Okay, you did max frequency, you did max length is 1, which makes sense. So you got the index and all of that, and you took the maximum frequency is whatever the max frequency is. Okay, so you're also keeping a track of the max frequency. Okay, while current minus start plus 1. I am not able to wrap around my head around whatever the fuck I wrote here. Okay, yeah, it's quite late. I'm getting tired right now for talking 2 hours. I'm gonna call it a break today, and I'm gonna try and continue with this problem from tomorrow. And yeah, I'm gonna think it from a fresh mind exactly how we can do it. I was going in the right direction. I feel like it. Only thing I was not able to figure out is that how can I track the max frequency and all that, right? Like, not even the part that we have to track the max frequency. My point here was that how we cannot, like, how do I know that I have exhausted this and I need to move this pointer, right? So yeah, let's see. Maybe tomorrow, maybe day after tomorrow, not sure. But whenever I have some time, I will be back again, and I'll start resume working from here. Yeah, so I think it was 24, 3 problems I solved, out of which one I already looked at it. I still do want to look at one of 2 problems, and so let's do one. Let's put a quick filter of difficulty. 1, 2, 3, 4, 5, 6, 7, 8. 8 problem. I feel it can be done very easily, right? So reverse a linked list is very easy. So let's do that first. So when I get stuck with problems, I try and solve a little bit of easy problems, something easier than what I am not able to solve. Kind of gives a boost in confidence, saying, oh, you can solve it. You can solve it. Just not getting the right intuition right now, right? So, okay. So given the head of a linked list, reverse the list and return this thing. Okay. So reverse linked list. This is a very straightforward solution, and okay, cool. So if head is null or head.next is null, say return. So list node previous is null, current is the head. So while current is not null, you keep on going. So how do you do it? you basically say current dot next equals previous. So this is where you reverse the pointer, right? And then you move the pointer forward, and current has to be current dot next. But you already lost this reference because you already reassigned it. So have to first store it somewhere. Return previous. And that's pretty much it of how you do a reverse of the linked list. Cool. Okay. So now, in here, we can also do a recursive solution. Let's actually quickly get ChatGPT to give us notes for this. This should be a fairly simple note, but yeah, use 3 pointers, blah blah blah. Okay, makes sense. So use 3 pointers, current, this thing, reverse links in place, classical and all. So you can also do a recursive solution in here. So I'm just gonna do a recursive solution. Recursive. So let's say this is the current, and let's say this is this. So if current is null, this is where you have to return previous, right? It's where you have to return previous. So you have to move the pointers. First thing here you have to do is current dot next is previous, and then you have to call recursive recursive solution. You have to call current dot next, and the previous becomes the current, and you have to return this. Now, just like the iterative solution, this is definitely more optimal because you do not use extra stack space. But since this is this, you have to, again, similarly, you have lost the reference. Current dot next, you solve this, and then here you say next and this thing, and that should be it. That should be it. You can also try to actually see if this works. So in here, recursive head and yeah, so this is basically the recursive solution. Cool. So confidence boost 1. Okay, let's try for the second one. So okay, counting bits, length of n+1 such that is the number of ones representation in I given it. So I'm gonna take this a little later because I feel there's a little bit of discussion needed in here. Okay, so contains duplicate is even more easier. True if any value appears twice in the array, return false. Since the range is so large, we have to use a set, otherwise we could have used a bit field to actually figure out, because in an integer you have 32 bits, so you can use those as an indicator to know if the values appeared or not, right? But here you have to use something else because you have 10.5 range, so you cannot do that. So yeah, let's do that. Contains duplicate. This is again a very easy solution. So if contains a duplicate, return true if any value appears twice. Okay, so set integer visitor is hash set, and here you can say this thing. It really doesn't matter, but because these are maps behind the scene and there are maths involved for two cars and things like that, I do not want to pre-initialize it with some length. If it was simply an array back thing, I would have done that, but for here I'm just going to ignore it. Okay, so now for int num int nums, if visited dot contains num return true, and visited dot add num and num return false. Yeah, that's basically it. It's a very simple solution in here. Can you give me, I mean, I can write it in here. User set to look back at visited values. Look back. O of 1 time complexity while space is O of n. Yeah. My bad, sorry. And we have to say O of n amortized, because the lookups can be a little bit slower than O of 1 depending on if how your array size is, how the backing array size is, and if there are any collisions or not. So it's amortized. Yeah, cool. Okay, so let's go for the next one, which is inverting a binary tree. Okay, so the root of the binary tree and return its root. Given the root of the binary tree, invert the tree. This again is a very, very simple solution. So invert binary tree. Okay, and in here, let's say this. Okay, so if root is null, simply gonna return. Otherwise, we have to invert it. So left would be the left and right would be right. So tree node left is root dot left. Okay. Tree dot right should be this. Right. Now invert tree left. Root dot left is this. Sorry, my bad. You invert it, right? So this becomes left, and you return root. That's basically it. That is basically it. Okay, yeah, cool. So yeah, we solved almost 6 of those, 5 of those I would say. One of those I still don't know. We didn't solve it yet, so we have to wait for it. I will go back and visit the longest increasing subsequence and the longest repeating with key thing again. Yeah, I've done that before, so I'm pretty sure I can bring in back the intuition and all of that. So that should be fine. Okay, so yeah, for the counting bits, I'm not doing it now. The reason behind that is I don't think it's an easy solution, but it's not an easy solution right off at the top of the head. So it'll take some time to explain on how I'm gonna do things and things like that. Okay. So for now, I'll be signing off. It's been almost 3 hours that I'm streaming now. It's almost 3 hours that I'm streaming. So I'll be signing off now. Thank you everyone for who joined live. Thank you, and hope you had a good learning session if you're watching it live and you learned something. So this was quite a good session for me. Solved quite a good bunch of problems. I forgot. Yeah, I forgot to do that. But yeah. Anyways, so we'll be continuing with the series where we solve a bit of LeetCode stuff. And soon I'll make a video on why I feel LeetCode is not really as bad as how people suggest it to be, and it's not really different from engineering. But yeah, I'll be working on that. It's again my opinion that, and yeah. Till then, thank you so much for joining. Thank you so much for joining, and hope you have a good time. Yeah, see you soon.